Good morning all of you. This is Dr. Nageswara, Assistant Professor of Physics and Electronics, SRR and Severe Government Degree College Autonomous, Vijayawada. Today we will discuss about the architecture of the microprocessor 8085. We know nowadays we are all depending on the computers. So these microprocessor will play major role in all computers that is personal computers. What is this architecture? What is the functioning of different parts in the this microprocessor? We will discuss in this presentation. So microprocessor is actually 40 pin IC. You see here, there is a 20 pins one line and 20 pins another line. So that is called a dual side pin. It is designed in 1977 by Intel Corporation. There is an 8-bit microprocessor only. Generally we called this is called CPU. Actually CPU comprises of along with microprocessor some of the integrated chips we have. So microprocessor is one of the integrated chips. It is connected with the miniature transistors in a single semiconductor. So we know all electronic devices are made with the semiconductors. Of course, this is manufactured with the NMOS technology. What is this NMOS? We know there is two types of semiconductors. One is N-type semiconductor and the second one is P-type semiconductor. So this is where we constructed this 8085 by using the N-type semiconductor, by using MOS, that is metal oxide semiconductor technology. And this is the block diagram of the microprocessor 8085. It has some different points. One is accumulator and temporary register, flag registers, ALU, that is arithmetic and logic unit, timing and control unit, interrupt control, serial input output control, instruction register and instruction decoder, and some general purpose registers, temporary registers, and program counter, star counter, and address buffer, data buffer. These are the different parts of the 8085 microprocessor. Of course, now we will discuss one by one how these parts will work in the execution of the program. You know what is this execution of the program? Program is nothing but to do something by using the computer. We will give some instruction to the computer. These group of instruction is called a program. So after executing this program, the result will come. In the execution, all these parts will play major role. So one by one we will discuss about this. The first one is called accumulator. This is the accumulator, where 8 shows the 8-bit. It contains 8-bit register. Because 8085 contains mostly registers. We know there is a different registers we discussed at various level. That may be just these registers are made with the flip-flops. So here there is accumulator is placed. It is an 8-bit register. It perform input output operations, arithmetic operations, and logical operations. After completion of these operations, the result is stored in the accumulator only, because we know register is worked as a memory card. So that after completion of these executions, that is maybe arithmetic operations or maybe logical operations, that may be stored in the accumulator. And of course, second part is that is ALU, that is arithmetic and logic unit. You know, in the name, that is arithmetic operations and logical operations can be done in this ALU. After completion of these operations, the result is stored in the accumulator. Of course, for example, you want to add two numbers, that is 3 and 4. Of course, the number 3 is in the accumulator, 4 is in the one register. That the 3 plus 4 can be done by using this ALU. After completion of these process, the result is stored in the accumulator. So that accumulator plays major role in the input output operations, logical operations, and the arithmetic operations. Of course, this ALU is connected with the accumulator, temporary registers, flag registers, and logical circuits. And These are the done arithmetic and logic unit can perform separate operations like maybe complement or increment or decrement, clear or left shift or right shift, etc. And the next one is general purpose registers. To make any operations, any execution of program or any addition or any subtraction, any logical thinking, we will use these registers to store some data. These registers are called general purpose registers. This is B, C, D, E, H and L. These 6 registers are called general purpose registers. All these 6 are 8-bit registers. So that we can did any 8-bit operations by using individually by using these registers. In some of the case, maybe we want to did 16-bit operations. In such cases, these registers can utilize as pair. For example, B and C, that pair can be utilized for 16-bit operation. And D and E, that is one more pair, can be used for 16-bit operation. And this H and L can be used for one more operation. That pair is also can be used for 16-bit operation. So that there is 3 pairs we have to did 16-bit registers to make operations. And 2 more registers we may see about the general purpose registers, that is the W register and Z registers. These 2 also 8-bit registers, but these 2 registers are not accessible to the operator or maybe programmer. For example, to do it any program, to write any program, we will utilize accumulator and these 6 registers. But these 2 registers W and Z not available to the programmer. These 2 registers only accessible to the microprocessor for internal operations. So that these are called temporary registers. And one more point, that is called program counter. It is a 16-bit register. You see here, this is the program counter. What is the importance of this program counter? The program counter will use to store the memory address location of the next instruction to be executed. What is this instruction? We know in high level languages or maybe assembly language, when we are doing program, when we are writing program is nothing but number of instructions, series of instructions. For example, someone is asked you to write a program to add 2 numbers 5 and 6. Initially what we will say? We want to step by step, that is the first step is the number 5 is stored in one register. That is STA in register something 4. That is nothing but STA4 is nothing but the number 4 is stored in the accumulator. And another 6 number can be stored in the register, that may be B, C, D, E, H, L, whatever it is. There is MVI, C and 6. That is number 6 is stored in the register 6. So that is the first, and STA 5 is the one instruction, and MVI C6 is the another instruction. That first instruction can be given by one memory location. And these move or maybe that is next one, there is MVI C6 is get in the next location. That may be taken as 8000. Second location may be taken as 8001. And that what is third instruction? Third instruction add those 2. That is add C. That instruction add C is nothing but the available information C, that is 6, will be added to the accumulator data, that is 5. That is called third instruction, whose memory location can be taken as 8002. When the first instruction is executing, that is STA, that is 5, and it is executing, the second location 8001 is stored in this program counter. So that is the importance of program counter. So microprocessor increments the program whenever an instruction is being executed. So that is the program counter will be utilized to store the address location of the next instruction to be executed. For example, when the second instruction, what we said? MVIC6. When the second instruction is going to executing, the third memory location, that is 8002, when entered into the program counter. So that is about the program counter importance. And third, next point is a stack pointer. This is actually stack pointer. It is also a 16-bit register. What is this importance of this 16-bit stack point register? Actually, stack is nothing but the part of the RAM. There is two memories we have. One is a ROM, that is ROM, random access memory, and third one is a read-only memory. Read-only memory can be utilized only to read the data. Of course, random, that is random access memory, can be utilized for accessing programming instructions also. That may be arithmetic and logical operations. So, this stack point, it is the portion of the RAM. And one more temporary registers we have, which is connected with the ALU. These temporary registers is also not connected with the programmer. These registers is available to the microprocessor to do internal operations and logical operations. So this is about the temporary register. These temporary registers can only be accessed by the microprocessor, or it is completely inaccessible to the programmers. So that is about the, not only here, even W and Z registers also already we discussed. These two registers also not accessible to the programmer. That is only useful by the microprocessor for doing self operations. And next one is flag registers. Actually, flag registers will be used to check the status of the program or current program. So how it is, actually when doing this execution of the program, someone will be happened. This is actually a flag registers. In this 8085 microprocessor, we have 5 flag registers. One is carry flag, second one is zero flag, third one is sign flag, fourth one is parity flag, and fifth one is auxiliary carry flag. Of course, because when doing the execution of the program, some instruction to be carried out. The first one is, in some of the cases, there may be carry or borrow during the arithmetic operations. For example, when we are reading two numbers, that is 9 and 7. 9 and 7 we are adding, there is 9 plus 7 is 16. This is nothing but there is a 6 is there and 1 is there. 6 is the sum, 1 is called carry. In that cases, we will use this carry flag. And when we are doing subtractions, when we want to take borrow from the next MSB, most significant bit, in such cases carry flag will be take more accurate. And next one is zero flag. In some of the cases, the result operation is 0. In such cases, zero flag will be activated. In some of the cases, the result may be negative or positive. If it is negative, this is significant, the sign flag will be hacked more. And next one is parity flag. If it is in even parity, that even parity flag will be activated. And auxiliary carry flag. If there is a carry or borrow from the bit 3 to bit 4 for arithmetic operations, this auxiliary carry flag will be used. So these are the importance of the different flag registers which will be available in the 8085 microprocessor. And one more important part of this 8085 microprocessor is instruction register and decoder. Actually, we know when in the previously what we said is that when by taking by writing the program, or means nothing but set of instructions, we use move or maybe MVI or STA. STA is nothing but store data into the accumulator. And MVI C is nothing but the store data into the C register. Add B is nothing but add the data available in B with the data available in the accumulator. Where there is MVI, STA or ADD or maybe subtraction SUB, these are all called opcodes. These opcodes will be held in these instruction registers. So these opcode, that is called instruction code of the instruction, which is being decoded and executed in the instruction register and decoder. So for to make any operation or any execution of the program, this instruction register and decoder has more importance. And the next part is, this is a timing and control unit. Of course, timing and control unit several pins, that is clock pin, general pin, and control pins, and status flags, DMA pins, and set pins, that is reset in and reset out. Of course, these are controlled by the timing and control unit. Of course, this control unit comes under the CPU section, central processing unit. It controls the flow of data from the CPU to the other devices. What is the other devices here? We know in case of our computer, microprocessor plays key role, there is no doubt. Not only that, there is another ICs we have available in the computer, otherwise we cannot do. That may be one IC which is belongs to the input output devices. To make one keyboard, one IC is required. And to connect with the internet cable, one IC is required. To connect with the that is MSB or USB device, one IC is required. So these are connected with these, can be run by using this timing and control unit. Those are called, of course, interfacing devices. When executing the program, or maybe by writing the program, when we are writing the program, some of the steps we have to go back. For example, when we are doing the division program, there is division is nothing but a number of subtractions. Division is nothing but a number of doing subtractions, several subtractions. In such cases, there is some steps we want to go back, that is called loop circuit. Is nothing but some interrupt is added, some interruption is happened when it is going to the next step. In such cases, we want to use some interrupt steps. These interrupts are actually 5 we have in case of 8085 microprocessor. That may be trap, RST 7.5, RST 6.5, RST 5.5, and INTR. Of course, depending on this, the priority will be given. Trap has the major priority, most priority, and RST 7.5 least priority, and RST 6.5 is most least priority, and the last priority is INTR. So, to control or there is some interruptions happen during the execution of the program, it can be handled by using this interrupt control. This is actually interrupt control what we have. And the next one is, we have here address buffer and data buffer. Actually, that is the mediator between these registers or program counter to the arithmetic and logic unit or accumulator. You see here, the content stored in the stack pointer and program counter is loaded into the address buffer or a data buffer to communicate with the CPU. To communicate with the CPU by using the 8-bit internal bus, that may be address bus or data bus. Means that there is some lines we have, cables, what we are in general, what we are saying, that is 8-bit cable lines, that is address lines or maybe data lines. We are going to these data from address buffer into the CPU. So initially what is happening, the data available in the stack pointer or program counter which is entered into the address buffer or a data buffer. That is about the importance of the address buffer and a data buffer. And next one is address bus lines or data bus lines. So this is actually data lines. Just in general lines we are called that cables. So to transfer data from one place to another place, we will use these data lines. So there is two lines. One is that is bidirectional data lines, and second one is unidirectional data lines. There may be data lines may be two types, address bus and a data bus. Here data bus carries the data to be stored. It is bidirectional, where the address bus carries the location to where it should be stored, and it is unidirectional. Of course, the data transfer can occur from input devices to output devices or output devices to input devices. That is about the address bus and the data buses. Of course, these lines are only 16-bit address bus. This is allowing it to address up to 64 kilobit of memory. So this is about the architecture of the 8085 microprocessor. In the next class, we will discuss about the orientation of registers in 8085. Thank you very much.